2, 1, go. Welcome everybody. In this session I will talk about organic causality. And we will see that the relation between causality in the observed reality, causality in the existing reality, and causality in reality is a mess. There's not so good behavior at least. There's a lot of rather chaotic possibilities. So I will begin by taking a chalk. Yes. Okay. So a process can be causal or not. Now, before I start, I have to say, so when you talk about causality, for me, I want to go to the point model, let's say the moment model. But people usually talk about the existing causality when they talk about the observed causality. So there is already in the language some problem. But let me begin. So I will look at A, B, C existing objects. I want to say that A implies B. A is causal for B, for example. That can be denoted by the double arrow. And the I is kind of the interval. I want to see whether A implies B is real, because it has to be an existing thing. But causality is supposed to be a real thing, but it exists at first sight only in our mind. So it depends on human analysis whether something depends on another or not. Because the real fact, we don't know yet. And we see something like there's a banana peel and I do 3 steps and I fall over the banana peel, and the cause was that I stepped on it or that the banana peel was there. But maybe the cause is completely different from many other parameters that we didn't consider. Not this is an easy example, of course. But yes, so first question is, when do you say that something causes something else? The rain falls because the clouds get a little bit cold and condenses the water. But why is the water there? And so, well, there is a lot of other things, but maybe it depends on the height or some temperature, so many things. So we decide that something causes something else on the basis of our model and of our own ideas at that moment. If you have other ideas, you may define something else. So that's already a serious problem with the observed causality. But okay, when you say something is causal, at least you have to be able to observe them. I will only for the moment say, okay, they exist at least. And so this is different from the existence intervals. Probably after these things. It's not that A and B exist, that you already know that they're causal. So that's what I want to stress again. When you say they're causal, you make a judgment in your mind. Not the reality doesn't do that. The reality does maybe something else, but you decide, okay, it's causal. And that is not, it's a result of a brain process, but it's not really related to the existence of A and B. It's outside. It's completely outside deduction or judgment that they are causal. That's a problem. But okay, I have A is defined on an interval IA. B is defined on an interval IB. Let's do it like this. And C is defined on the interval IC. Now I want to talk about causation, and I have to make a difference between different possible types of causation. I want to talk about direct causation. Direct. What does that mean? I want it to be immediately in the manifestations and not 500 manifestations later. I can wait 5 years and maybe some effect could be causal. Who knows? I don't want to do that. It's possible, but not very practical. So direct causation means that this interval starts inside this interval. And then it's possible to change this, because if I look at this interval now, this is also, we said that the tail of an existence interval is also an existence interval. This is also an existence interval, existing for B. And if I look at this here, this is existence for C. So I can replace this whole system by consecutive intervals. By A. And then I take that interval to the end of B. And this is also IB. I should put a prime here, it's another interval, but it's an existence interval. Because we said the tail of an existence interval is only the end point. The beginning point of the existence interval is not fixed. You can come as close as possible, but you cannot come, you must stop at some moment coming close. That is a minimal interval. The minimal interval can be here somewhere. A minimal one. But it doesn't matter. We have now a sequence of intervals for A, B, and C, and they are consecutive. So you replace this situation by the consecutive situation in the case of direct causation. If it's indirect causation, and not indirect, the situation that you will get is something like this. Separated intervals by some other things which you don't really use. So this, of course, you can still do the theory, but you have to always mention the interval which is not directly connected to this. So this is easier theoretically to talk about, and it's also more logical that when some interaction is going on, then inside the manifestation intervals, the interaction is already beginning to create the causality. So then it is an assumption, but it's a very plausible assumption, because you don't want to wait for years before the causation begins. Okay, so direct causation. Suppose you see some interval IA, and you have the object A existing there, and you want this to cause the C by C. Okay, so if you want to study the causal relation between these A, B, and C, you have to look at these intervals, and this in this transitive causality is transitive. So if I have this causes that, and this causes that. So this causes this causes that. Now I have to see whether the A causes the C, if this would be a causal relation. Now this is of course a problem, because this causation does not depending on B and by B. So if I don't use this intermediate, I cannot conclude the causality, because I have to go via this step using the transitivity of causality, which is assumed. Causality is transitive. So okay, but I cannot check this on the theory as it is, because the causation from A to C should not depend on any intermediate B. There is no idea why, if I want to prove that this causes that, why does it have to go via B? And which B? Which ones? So if I have to define now on the non-existing level something which goes deeper than the existing level, then I have to worry about this. So what is the obvious solution? The obvious solution is to use all intermediate things. So solution, use all intermediate means. Of course you can never find them, but that's not the problem. I want the theory for causality on the moment, and I know from the beginning that all the things I say about moments and existence will be never observable. So that's the problem. Also one of the reasons I didn't mind not doing the measuring, because this is even worse than observing your interaction with it. And you change it, as quantum people well know. So okay, that is the idea. We will use all the intermediate things. Okay, so I have to find the way to do that. So when I have an object A on an interval I will define now the organic cause. So this A is an existing thing, it happens. What causes this A to exist? Well, that's in the process, of course. But I will say this organic cause is, okay, this A comes from AT. So I will write C0 IC. So the object on which is causing C, Ci, I denote it by C0 IC. What is this? This is the set of all x's t double in st double, such that there exists an I in interaction with xt double and ct double. Okay, so I have some object C defined on the interval I. There's all moments. T double is a moment in the interval, and I take all T double, and there is an element in the moment T double such that it interacts with an element of C. T double is the element. So you want to say that everything that interacts in the interval with the object here, the Ci, so the element of Ci, everything that interacts with it, I put it in the potential, in the C0. So that is what I call the organic object of organic object. Okay, so now, so this is the idea. Instead of using some certain specific elements, I use all interactive elements and I add them to the story. And now I define the organic causality using the full set of all these interacting things. So the definition is going to be, so I say AI causes organically for B on the statement by B. I denote the interval behind the element. And remember, I'm writing very poorly. So the object A on the interval IA is caused organically by okay. no, B is caused by A, yeah? A causes organically B. Well, if what happens when I have this set B0 on IB is inside the maps SIA, IB, the S is the connection maps of the A0, yeah. Well, I wrote this with a capital, it doesn't matter. So, okay, you see, this is a little bit strange. What does it say? It means that S T double or A0T contains D0 T double for all T double in the interval. Okay. So this is clear. This means that everything that interacts with something in AT by the maps goes to something, but it must not necessarily interact with the B, but everything in the B everything interacting with the B at T double comes from or is an element coming from an image of the connection on the A. So that means that all the interactions in A with respect to something in B are mapped onto a map bigger than this. This is contained there. So that it looks as if the interactions in B with the outside there are all determined by the interactions in A with the outside. And that is causal. That means that A causes this. So this is a technical definition using the moment process. Maybe I'm going a bit too fast, but it's just this idea is that the interactions here with outside come from interactions here with outside. So all, in fact, so in this causality principle, all these interactions play a role. That's what I need. So that replaces the consideration of all the intermediate B's because the interactions will be there. So I take care of this by all the interactions here with the outside coming from some interaction with the outside in A. So that is the definition. And I guess it is also rather plausible. This is the way you would avoid all these problems with the intermediate B's. Okay. Then there is immediately an easy thing to verify. I'm not sure I want to do it. So you verify this is not transitive. For different reasons, for at least two reasons, but maybe one is enough. But this is not transitive. Organic causality is not transitive. So, not with partial order. So in reality, this causality, the real causality should be the organic causality, but it's not a partial order. So that makes it dangerous for us to talk about it with the logic we have of order. This is not a partial order. So when you talk logically about it, so with our language as we usually do, we have to be very careful. So I note that in the book I also say this. It's possible to talk about it, but be careful. Not use the hidden transitivity somewhere. So well, the thing is, why is it not? So this causality is defined by this inclusion. But here is a correspondence. And correspondences do not preserve inclusions. So that is the main reason here. Reason one. The other one I will not, it's more technical. Correspondence does not respect inclusions. And when you write exactly with this definition, called the transitivity, then you have three things, and you have to do this twice and so on. And so you will see that the fact that the correspondence does not, for example, you have the inclusion on the first, in the first part of the causation. You have three things on the 1 to 2, but on the 2 to 3 you cannot do the image of this will not contain the image of that. So because the S do not preserve inclusions, and that destroys the transitivity. So this is rather chaotic or bad, if you like, but it's a fact. Then what does follow from this for the relation between the causality, observed causality, existing causality, and in the book I give more descriptions about how things fail. But you can, for example, what can happen? OA is the observation of the object, observed object of A. OB are the observed objects in some interval. And then it's possible that you find causal, this observed causal A, OA, OB. So A, the observed object, causes the observed object B, and A not organically causal for B. That is, so observed causality need not correspond to real causality of any type. But maybe you can get this in with some small assumption, perhaps up to time shift. Because when processes which are causal, they are not any process, they are sort of special. So it's not so unusual that perhaps you have to make a small assumption on the processes too. All the processes which are related to a certain process with interactions are not causal for it, but some are causal, so these are special. And if you have a little bit extra assumptions, you can find a time shift causality, which is not bad. It's like causality, but of course, if you don't have control over the time shift, you don't know when it will show. And that means for observations, again, big problems. But okay, it's what it is. So all causality will disappear after a time. We said we want to observe direct causality, not waiting for a year until we begin to observe and think about causality. So, of course, this direct causality can be investigated and found sometimes, and not forever, because it will be destroyed. So, this OC and causality of any type, OC can vanish after time. But that is normal, and it's the same for causality and existing causality, and causality, observed causality. And even the momentary causality. All causalities can vanish. They are not processes, but they are not processes forever. There are some conclusions for this that I will use if I find the eraser. Where did I put it? I don't find it. I am blind. Okay, not necessary. I will use this in, for example, some things like evolution theory. Already in the next lecture. I will use it in free will. I will use it in a failure of probability. But there are many reasons for this to fail. Probability theory cannot be applied to reality. Unless you assume it's an approximation, which it is, of course, but then you have to say that. And also the same thing here, the existence of random. Because I said last time, everything has an intrinsic reason, because you can go to the creative potential in the beginning of a process. There is always a beginning of a process unless it was going on forever in the past. Okay, then you cannot go back till the end because there is no beginning. So, but okay, if there is a beginning, let's say, which most people assume with the Big Bang or whatever, Big Exodus, then you can go always back to the beginning of the process. And that's a creative potential with no history. And these creative potentials are creating the whole process, all the processes in the universe. So everything comes from creative potentials. So everything has a reason in moments. The reason starts in moments and it gives you the processes. So everything is explainable. It's nothing that is random. It has a very specific structure, starting with something and then the process continues. So, okay, random is a problem in reality. You can say random in observed because your observations are, first of all, very incomplete and very wrong, as we know, because there's a lot of existing things in one observation. We think we observe one and we have in fact a whole super object. So random is not existing in our theory, except if you want to do it in the observed reality and say, oh, that is random. Okay, maybe, but that is failing in the others. So, okay, that is the problems we will, not problems. It will be interesting in evolution theory. Free will, there are several arguments which will show that there is free will. And one of them I already told you, the creative potentials. If we start an idea in our brain, the brain activity starts with a creative process. The brain activity is not defined by the past brain activity. You start a new brain activity when you have a new idea, for example. Or it doesn't have to be very original, it's just a new idea for you, and okay. So there are many reasons for free will to be there in the abstract sense. Free will be an abstract property. Free will does not exist. Failure of probability exists of non-existent of random. Okay. Finally, I want to finish with some other consequences. If I have some A on an interval I, and it goes to B interval I prime. So this B is the cause, A is the cause, this is a causation, let's say. A causes the B on its interval. Then it's possible that B realizes before A. I'm finishing in a moment.
Yeah.
B realizes before A is possible. We don't know the length of the interval, so okay. That means, also for the observations, or B can be observed before A. So we have the cause, the consequence. The cause is obvious because the process begins on a moment before the other process. So on the beginning of the process you can actually see that it cannot be the reverse. The first beginning process should be the cause. And the existing things is already a problem because the consequence can exist before the cause exists. So that is something rather funny. And this is again a proof that reality doesn't care so much about existing. And well, it doesn't really matter. Of course, then you can also say, oh, well, I can observe the consequence before the cause. Fine. That's a problem for the observer, not for the reality. The reality is clear. AI causes, with the definitions I gave, causes B on its interval. So this is something quantum theorists seem to worry about. They have, I think, an experience of Molière, which sort of proves the future interacting with the past. And for me, the experiment is fine, but doesn't prove that at all. It only proves that you can observe something cause after observing the consequence. That doesn't mean that the future of the consequence interacts with the past. It is just trouble with the longer observation intervals. So I think I have to stop here, and then next sequence is in a moment.